Is there an upper size limit for black holes? Why don't we build multiple identical missions to increase the chance of success? Is the universe considered finite or infinite? And in Q&A Plus, is the universe expanding or is everything else just shrinking? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Ascendant construct. Why don't we send multiple lunar and Mars probes simultaneously, increasing success and allowing for exponentially more collection of data and information? Because it's expensive. That sending one mission is all that people can afford. That, when we talk about potential cuts to funding, there's only so much money that people have to be able to send a mission. And so they have to work within that budget. And the budget allows you to make one mission and you send that mission. Now, there have been plenty of examples where multiple identical missions have been sent to do the job together. Think about Spirit and Opportunity, which were two essentially identical rovers that were sent to the surface of Mars. And they were both doing roughly the same job. The Voyagers are identical. The Pioneers were identical, that the Mariner spacecraft were versions of the same kind of chassis and platform. And so if the budget is there and the redundancy is called for, then they will build redundant missions. Otherwise, you have some science objectives, you make the bare minimum mission that you can that achieves those objectives, and you hope that your spacecraft doesn't run into any problems so it can do the science. And generally that works out. Lubo in China, how is the Seastar S50? Have you tried the EQ mode yet? So you can see behind me, I've got my Seastar S50, and it's an amazing little telescope. I've probably had it out now 10 nights and worked on a bunch of objects. The Iris Nebula, the Pinwheel Galaxy, the Whale Galaxy, and a Flat Galaxy, the Whirlpool Galaxy, and it's an amazing little piece of technology. And you can really feel that this is the future. I mean, there are these existing other automated telescopes, like Vaonis has one, Unistellar has their telescopes, and there's the Dwarf 3, which is sort of a competitor to the S50, to the Seastars. But the Seastars are cheap. Comparatively, they're only about $500 US compared to the other ones, which are in the several thousands. The Celestron Origins telescope is going to run you $5,000, $4,000. So, for regular people, it's a good telescope to use. And you can just sort of put it out and you plug it in, give it a series of targets to go and track down, and then you go to bed. And then you get up in the morning and you look at the pictures that you took. And that's perfect for me as a morning person and not a night person. As long as the weather forecast is good, I put the telescope out every single night that I can. And I can sort of plan it out. Like I know where the moon is going to be and I know which constellations are going to be visible to the telescope for the longest period of time. And so I set up the telescope in a place where I can capture the part of the sky that I want to see, something that's as close to the zenith as possible so I get the clearest seeing. And it's magic. And then sort of day after day, when you're working on the same objects, then they just get more data and they just get more and more improved. Now, it's an entirely new rabbit hole that right now I'm just letting the onboard software stack up the images and improve them. But I could download all of the raw FITS files, bring them into something like PixInsight and do my own image work. And a lot of people do, and they produce some really incredible results. It just shows you that if what you have is time, then you can use fairly small optics. Seastar is only a 50 millimeter lens, but you can run this thing for hours and hours and hours to produce really incredible images. And this is the future. Like I will never polar align a telescope again. It's ridiculous that you have to sit out there and try to line it up and you try to make sure that it's in the right angle and people want to look through your telescope and you're like, just a second, I'm just going to get this polar aligned. And an hour later, you're frustrated and you just, people just wanted to see Saturn. And with these guys, you beep boop and it goes into the target that you want to see. What I think is like my dream, and I'm sure these exist or they're in the process of existing, it's a mount that has this intelligence built in, and then you put your telescope on top of it. And so you can swap out, or you put your camera on top of it and it's able to sort of track automatically. Now, the EQ mode is where you take the telescope and you put it on a tripod and you put it at the same angle as the tilt of the Earth from your location. And then instead of it using the alt azimuth, where it kind of goes over, down, right? It has to move in two directions to be able to track anything. It only has to move in one direction because you've already got it angled to the tilt of the Earth. And it makes for very smooth. You can do much longer exposures. And I haven't done it yet. One, I don't have a good mount for it. I mean, I would have to steal my camera mount. But also I'm pretty happy right now with the alt azimuth mount. Now, if I want to do better pictures, I'm going to want to go to the EQ mount, but I haven't done that so far. QC Ream, how long could humans stay in deep space radiation-wise? We don't know, but we do know that if you are in deep space, you're experiencing about 200 times as much radiation as you experience on the surface of the Earth. That's a lot. And that's the average. That's the background cosmic ray exposure that you're experiencing. You're also susceptible to solar storms, and a bad solar storm could just kill you. When we look at the kinds of storms that were striking the Earth from the auroras last year, that is a huge flux of protons that are just being blasted off of the sun at relativistic velocities. They're going to go through your tissue. They're going to knock off parts of your DNA, and you will then have both radiation damage. We know that that is incredibly dangerous. You could just die from radiation burns. But then there's going to be just all of the cumulative DNA damage that you're going to take from being there in space. And NASA has requirements and restrictions on how long people are able to, how much of a radiation load astronauts are allowed to get in their lifetime. And they watch this very carefully. The astronauts wear radiation badges on their spacesuits, and that's tracking their individual radiation load. And then when they come back to the surface of the Earth, they check out how much radiation they got. The Apollo astronauts had these, and I'm sure they have them for the current astronauts on the International Space Station. And once we consider missions to places like Mars or the asteroids or things like that, then there's no way that the astronauts are going to be able to stay under the maximum radiation load that's permitted by NASA. They're going to go way beyond it. And so this is going to be an individual risk that each astronaut is going to have to make. They're going to know that they will have been exposed to far more radiation than the human body is normally expected to take. And the consequences are cancer, right? The consequences are a few decades later or a few years later, the cancer starts to pop up in your body because you've had all of this DNA damage. So how long? I mean, you could probably live your life. I mean, I don't know, like as long as you don't get an acute radiation sickness from a solar storm, then you're just going to experience this ongoing damage from cosmic rays. And I don't know, like, how long you would actually be able to survive getting that kind of a radiation load. Like, could you just live your whole life and just be lucky and not get cancer? Or are you just going to have, eventually the DNA damage is going to build up and you're going to, suffer problems with your eyes and problems with your brain? I mean, there's been some really interesting research that's been done about the potential damage that astronauts are going to experience. And I know that doctors are concerned that even like a 9-month mission to Mars, there's going to be problems with their cognitive ability, problems with their renal system, liver damage, that there's going to be this ongoing radiation damage that's going to happen to the astronauts during one of these missions that they're then going to have to recover from in some kind of protective environment, hiding under the regolith until their body can heal the damage that they experienced. And even, the astronauts that went to the moon, many have experienced cardiovascular issues, other long-term effects from their time spent in space. Space is the death zone. When you think about mountain climbing, right? Like above, whatever it is, 8,000 meters, when you get to, or 7,000 meters, when you get to a certain height of a mountain, the air is so thin, your body is just starting to eat itself up. You can't survive in that altitude for long. And space is kind of like that, especially away from the protective magnetosphere of Earth. It's time to shout out our new patrons at the $5 level and above. Anthony McKeag, Peter Prime, Scott Wickstrom. Just what do you think you're doing, Dave? U007D, Sue Roland, Regal, Ilya Prince, Craig Anderson, and Lou Hamley. Join our community at patreon.com/universetoday. Abdul Samad Kulia, is space considered infinite? We have no idea. We have no idea how big space is. So there's a couple of possibilities. One possibility is that space is finite, that the universe is a certain size. You can imagine a sphere, while the observable universe, the part that we can see, goes off 46.5 billion years in all directions, right? That is just what is visible to us over the time of the universe, but that is just a smaller part of the larger universe. So you consider there's the observable universe, and then there's the actual universe. And the observable universe is this little ball, 92 billion light year across ball in this much larger cosmos. And we don't know how much big the much larger part is. So one possibility is that the larger universe is another ball that is bigger. Maybe it's hundreds of billions of light years across, thousands of billions of light years across, millions of billions of, is it quadrillions? Bigger. And the problem is that, our best attempts to measure the size of the larger universe tell us nothing. That it is, or at least they tell us that it is not finite. That, if you were standing on the surface of the Earth and you were attempting to measure the curvature of the Earth, you could do that, right? And these experiments have been done. You can go and measure the length of shadows, and you can calculate the circumference of planet Earth. Even though it feels flat, when you stand on it, you can actually measure that size that the ball is. And astronomers have tried their version of that experiment to try to measure the curvature of the universe, to try and get a sense of how big the real universe is. And they haven't been able to find a minimum size to the universe. So one possibility is the universe is finite and it wraps, that if you go in one direction long enough, you'll return to your starting point. And the other possibility is that it's infinite, goes on forever. It's always been this way, it still is. Brenda Cult. Astronomers used to talk about the universe as finite but unbounded. Now they talk about the universe being infinite. Why the change? I don't think there was a change. That some astronomers think that the universe is finite, and by unbounded meaning that it will just keep growing and will never stop and then come back down to a infinitesimally small point. That it will just, it's going to keep growing forever with the momentum of its expansion. And I think that that future of the expansion, that's what people were trying to measure when they did these really detailed cosmological surveys back in the, when they were looking at Type 1a supernova back in 1998. And they were trying to calculate that, will the universe coast to a stop and then all the mass will pull back together? Or will the universe just kind of keep on slowly approaching stop but never quite reach it? Or will it just keep growing and growing and growing? And what they found was, in fact, it's accelerating, that there's some mysterious force that's accelerating the expansion of the cosmos. That's dark energy. And so that answered that question, but that doesn't tell you whether or not the universe is finite or infinite. That observation is identical, whether the universe is a finite size and it is just, the things in the universe are slowly getting farther and farther apart, or whether the universe is infinite and the things in the infinite universe are getting farther and farther apart. And so we know that the universe, the density is going to decrease over time at an accelerating rate, but we don't know what the actual complete universe is, whether it's finite or infinite. Stephen Lewis. If you could stretch a telephone cable from Earth to the Moon or Mars, would the communications be instantaneous or delayed by the speed of light? Delayed by the speed of light. And in fact, even slower, because when you move light through some kind of medium, like a communications cable, it runs slower. Fiber optic cables aren't running at the speed of light. They're running, I forget the exact, it's like 40% the speed of light or something like that. That the fastest way of communicating is directly through the vacuum. And so you would actually have it be slower if you tried to stretch a cable to some other place. Dark Jedi Order. Okay, easy question. What's your favorite galaxy, not including ours, and why? It's probably the Sombrero Galaxy, but maybe it's Andromeda. Sombrero is really cool, It is this really weird looking galaxy. You know, we're seeing it nearly edge on. I think it's 6% at an angle of what we're seeing. And it is probably the brightest galaxy in about 30 million light years. And it happens to be about 30 million light years away from us. So imagine this sphere about 60 million light years across. And if you look at all the galaxies in the sphere, the sombrero is the brightest one. And yet we're seeing it almost perfectly edge on. And it has a billion solar mass, supermassive black hole at the heart of it. And then this weird ring of dust around the outskirts of the galaxy. See, I've thought a lot about this galaxy. And yeah, I would say the sombrero is my favorite. And I've taken pictures of it. Like, that's the part that's crazy, is that we can take, you know, we can just take pictures of these things. Like, you see pictures in the Hubble Space Telescope, like, that's an amazing galaxy. Well, you can take, you know, with something like this, the C-Star, or just some other telescope setup, you can take a picture of these galaxies and nebulae and things like that. It's just kind of amazing. It's like when you show a person Saturn for the first time in a telescope. They can't believe what they're looking at. If you've ever been there, in the presence of a person who is looking through a telescope at Saturn for the first time in their life, and they are seeing the planet and they're seeing the rings, and it looks just like it looks in the pictures. You know, obviously not quite as good, but they're seeing it with their own eyeballs. It's there and it's kind of wiggling in the atmosphere. It blows their mind. That's the thing that I find so great, is all the stuff that we talk about, all these pictures that we report on, all of this, they're all out there. You just have to take your telescope and point it in the sky. I know I'm like rabbit holing now, but it's so funny when you have an argument with somebody, or you don't even have an argument, when you post a picture of a thing like the Pillars of Creation, and somebody goes, space is fake. Like, tell me you don't know anything about space without telling me you don't know anything about space. Like, that picture of the Pillars of Creation, you could point a telescope that you could buy, and you can see the Eagle Nebula, and you can see the Pillars of Creation. I've taken pictures of the Pillars of Creation on a tiny little telescope. They're there. They're not as good as the Hubble version, but they're still there. So yeah, space is not fake, because like, anyone can just do it. Anyone can just go and look through a telescope and look at this stuff on your own. Anyway, Sombrero Galaxy, that's the one I like. Paul Wilson, is there an upper limit to how big black holes can get? No, there's no theoretical limit to how large, how massive black holes can be. That you could feed all of the mass and energy and dark matter and dark energy into a black hole, and it would just become more massive. That nothing weird would happen to the black hole. If anything, it would make it more stable, more long-lasting, that it would be able to last even longer before it evaporates away. So it doesn't seem to be any limit to what a black hole can eat. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. And this week's bonus question: is the universe expanding, or is everything actually shrinking? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who put your questions into the YouTube comments. Everybody who joined me for the live show when it happened several months ago. Now, we're on our live stream hiatus right now. We'll be back in about 2 weeks. So just got a couple more weeks to go. Now, I'm going to talk about some pretty cool things you can see in the sky. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Roofing, Brian Bodie, Karen, Chuck Hawkins, Commander Balock, Cy Nielsen, David Giltonet, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Monzo, Nick Borquez, Nick Solari, Paul Robach, Rank Haidu, Robic, Sean Sargent, Stephen Fowler Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So there's some pretty cool events that are going to be visible in the sky for the next couple of weeks, and I just wanted to bring you up to speed on them. Now, you don't need a telescope for any of them, although a telescope will be handy for the first one. So the first thing to let you know, and this is going to happen right away, so like tomorrow morning, get up before the sun, and you can see Venus and Jupiter together in the sky. They're having a conjunction. So whenever you're watching this, whenever the next morning, go watch it, and they will be very close together in the sky. And they're going to be those two bright stars up in the sky in the morning before the sun. And it's funny because like whenever this happens, every 18 months or so, and people will suddenly start to freak out on social media. How come I never noticed those two bright stars before? They're not stars, they're planets. They're Venus and Jupiter, the two of the brightest objects in the sky, and they happen to be very close together, and so it looks very cool. And in fact, if you time it right, it might be a little too late when I'm telling you this, but you can see them both within the same telescope view, which is cool because you can see the crescent of Venus and the bands on the surface of Jupiter and the moons of Jupiter. It's very cool. And the next event is happening on the night of August 12th. So tonight, if you're watching this, the day that we release this episode of the QA, and that is the Perseids meteor shower. And this is my favorite meteor shower of the year, not because it's the one that has the most meteors, but just because it's the one that has the nicest temperature for me in Canada. And so it's very warm. You can go out, lay under a blanket, look up at the sky, and watch the meteors. You'll see about 60 to 100 per hour. And the moon is not going to be great, but the moon won't show up until probably, after midnight. And so chances are you've already fallen asleep watching the Perseids. So if you haven't already got plans tonight, go watch the Perseids. And they're a peak. So if you're watching this the next day, you can still go out and see the Perseids meteor shower. People ask me, does it matter where you live? It doesn't matter where you live. As long as you can see the night sky, you can see the Perseids meteor shower. Northern hemisphere, southern hemisphere, doesn't matter. You don't have to look in any specific direction. You just have to look up and be patient, and you should see dozens of meteors an hour. And some of them should be pretty spectacular. And then the last thing to check out is Mercury. And on August 19th, you're going to see Mercury at its longest elongation. And this is when it's the farthest point from our perspective in the sky. Essentially, it reaches its highest point. And Mercury is always really tricky because it is closer to the sun than the Earth is, and so we always see it close to the sun. But I can't see it from where I live. I have mountains on both sides, and so when the sun is setting, there's mountains in the way, and when the sun is rising, there's mountains in the way. But I've only seen Mercury like one time. But if you have a good view to the horizon, maybe to the ocean, or if you live in a place with not a lot of mountains, you should be able to see Mercury really any of these mornings, but the 19th is going to be your best shot. So give that a try. Get out there and watch some of these events. All right, we'll see you next time.